This video is a brief demonstration of how to set up a 2x2 table of disease incidence by exposure status and to use the table to calculate relative risk. This is a 2x2 table. It's a 2x2 grid of cells. Typically, we use the columns for disease status and the rows for exposure status. And typically, we put the yeses and nos as such. Our 2x2 table is now ready for numbers. These are simple hypothetical numbers of disease occurrence among those who were exposed versus unexposed. Box A is the number of people who were exposed and developed the disease. Box B is the number who were exposed and did not develop the disease. Box C is the number who were not exposed and developed the disease, and box D is the number who were not exposed and did not develop the disease. When calculating relative risk, we're interested in the ratio of incidence in the exposed to incidence in the unexposed. Incidence in the exposed is calculated as the number of people with the disease among the exposed divided by the total number of exposed. In the 2x2 table shown here, this means box A divided by box A plus B. In this case, the incidence in the exposed is 0.2. Incidence in the unexposed is the number with disease in the unexposed divided by the total unexposed, or C divided by C plus D. In this case, incidence in the unexposed is 0.1. Our relative risk is the ratio of these two incidences. When divided, we get a relative risk of 2.0. Relative risks greater than 1 mean that incidence in the exposed is greater than incidence in the unexposed. Relative risks equal to 1 mean there is no difference in the incidence among the exposed compared to the unexposed. Relative risks between 0 and 1 mean that incidence in the exposed is less than incidence in the unexposed. So our relative risk of 2.0 means that the incidence in our exposed was 2 times greater than our incidence in the unexposed. In other words, the exposed were twice as likely to get the disease as the unexposed. Let's look at another example. In this case, both the incidence in the exposed and the incidence in the unexposed is 0.2. When we calculate the relative risk, we get 1. So as you can see, when the incidence rates are equal between the exposed and unexposed, the relative risk is equal to 1. In this example, the incidence in the exposed is 0.1 and the incidence in the unexposed is 0.2. When we calculate the relative risk, we divide 0.1 by 0.2 to get 0.5. This means that the incidence in the exposed was 0.5 times that of the unexposed. In other words, the exposed were about half as likely to get the disease as the unexposed. One important point of caution is that it is not useful to simply memorize the formula of A over A plus B divided by C over C plus D. Sometimes a 2x2 table may be displayed as it is here, with disease represented by rows and exposure represented by columns instead of the opposite. In this case, the formula would be A over A plus C divided by B over B plus D. In this 2x2 table, I've switched the yeses and nos. In this case, the formula would be B over A plus B divided by D over C plus D. Finally, in this case, I've switched both disease and exposure and the yeses and nos. In this case, the formula would be C over A plus C divided by D over B plus D. It's best to avoid all of this confusion and understand the concept behind the formula for relative risk. If you understand that relative risk is the incidence in the exposed divided by the incidence in the unexposed, and you know how to calculate incidence, then no matter how the 2x2 table is set up, you'll be able to calculate relative risk. But if you really like the formula with the letters, it's important to make sure that your 2x2 table is set up as shown here. If you are given a 2x2 table that is set up differently, you'll have to rearrange the table so that it's in the format shown here.